He's a 30-year history of leading startups in the North Bay. He came to Marin in the 1990s and led a company called Zep Solar, which was a solar energy company, and it got acquired by Solar City for over 150 million bucks. He's now doing another startup called Ojjo, which is a solar foundation company, and they've raised a lot of capital, I think over 70 million. And so he's going to come up and talk to us about his entrepreneurial journey and educate us on the rich history of electric companies and solar companies in the North Bay. So please welcome Mike to the stage. Come on up.
Thank you.
Yes. Where's the remote?
Oh, great.
Here and just to the right.
Great, thanks. Thanks very much for the warm welcome. By the way, I feel a whole lot better about being a human living here in the North Bay, having heard the last couple of startups go through their story and what they're planning to bring to the market. I'm incredibly impressed by what you guys are all doing. I wish for a lot more success here in the Bay Area and specifically here in the North Bay for folks who decide to take that kind of courageous step, which is to go start something. So I've been asked to talk a little bit about the startup journey and maybe a couple of startups that feature in the North Bay. And the focus here, I've been doing climate tech, I think, before we started calling it climate tech back in 2006 or so. Just personal note, I was deeply affected by Al Gore's book and ultimately the movie An Inconvenient Truth. I was working at a going nowhere startup at the time that was working on RFID, multiplexing RFID signals and reads and deduplicating that so that Walmart could be more efficient in tracking their goods. And just never going to happen. And even if it did, would anyone notice? And I had one of those moments where, I guess personal disclosure, I got fired from my job as a VP of business development because there was, you probably guessed it, there was no business to develop. And that doesn't stop you from having those moments, those hard moments with yourself, like when you're looking into the mirror. And mine was, I was midway through a career where I'd been doing a bunch of venture-backed startups and really loving it. I love the energy. I love the frontier technology notion, and going out and building something that nobody in history has ever seen. Those things were very appealing to me. But I did have that moment with myself where I sort of said, okay, you've been betting the mortgage and the kids' education, your retirement, on technologies that you didn't even know existed 6 months before the recruiter called you. So like, when are you gonna go do something that reflects your own values? And I think this is actually the extra step that hopefully many in this room, but I think eventually one has to take to get to something that not only sticks because of the enthusiasm, because of the youth, because of the growth, but also sticks because it's very soul linked. It's very purpose linked in your own life in a way that's impactful and can't be marketed to you. You can't be cajoled into committing to that kind of an exercise. So for me, it was exactly that. So go start some things that will actually improve the world and actually address the largest crisis that we face in our lifetimes and maybe in the history of our species. I want to focus on two companies here I've been asked to talk about. One, Zep Solar, the other, Ojjo. They both are in the solar space. And if there's a takeaway here, it's here in the North Bay, Marin and Sonoma counties, there are resources, there are people, there are professionals, there are ideas that are here for the making and markets that are here for the taking. And I think sometimes quietly, we are succeeding. Like the people in this room, I'm sure, we fast forward 5 years, there are going to be ideas here. There are probably ideas right here in the front row that are going to change things and hit real market penetration. And you're going to know about these folks. You're going to know about their accomplishments. But I think there's something that we should take heart in, is that we're actually getting this work done. We are, as a community, we're actually succeeding, and we're spawning yet more success, yet more experienced people who are doubling down, tripling down into new opportunities, and we'll talk about a couple of them here. So the first of those is a residential solar mounting systems technology called Zep Solar. It's a picture of an array that uses our technology on one of our installs. But back in 2009, I kind of locked arms with a technical founder, a guy by the name of Jack West, longtime solar engineer, very, very creative inventor. And he had deduced something just by looking at the numbers in residential solar installations, a field that he was quite skilled in and had been designing systems for about 20 years. And that was that, and this is famously true, and by the way, this trend has continued. Back here, when we're looking at 2004 to 2009 and then projected, we were seeing that panel prices and all other components were dramatically reducing in cost. But what was happening as a companion to that was labor as a percentage of total install cost was climbing steadily, and it was stubbornly high. Labor, as we well know, here in the Bay Area and here in the United States, generally speaking, is a pricey commodity, and it does not obey the laws of scale. It does not tend to price itself down over time. So this became a real profit issue, a real margin issue for a lot of solar installers that were having a hard time applying their trade in a way that gave them a real reason to believe. And this is kind of a picture of why. How many people in the audience have solar on their roof? I expected a lot of hands to come up. So you're probably familiar with a picture that looks not unlike this. And if you did it 10 years ago, 15 years ago, by the way, good move. Like, thank you for being on the vanguard. But it was something like this. 4, 5, often 6 people show up in your front yard, climb up on your roof, and they spend 2 or 3 days putting long pieces of rail, attach them to the roof and flash them so you don't get leaks in your roof, run grounding wires between each one of those rails because we're mounting an electrical system and everything needs to be grounded, brought all the way down to the ground for the safety of the workers and for the safety of the homeowner later. All of that needs to be done, and it involved the combined efforts of way too many people and way too much stuff. If you take a look here, the lower right-hand corner, this is what any installer would just refer to as the wall of rail. So 40-foot long sections of aluminum that you need to bring down off that wall, cut to fit the roof of the place you're going to go to, and spend the next 2 or 3 days working at. So way too much material, way too much labor, and very difficult marketplace in order to make money. Here's what Jack theorized, and he and I sat down together and built a plan to go try to popularize. And that is, what if the solar panel already has aluminum on all 4 sides? It's got a frame that's already quite sturdy, quite stiff, capable of bearing its own weight and bearing up against wind loads and other things. If only you could connect one panel directly to its neighbor and then smoothly connect it to the roof, you could avoid an entire stratum of rail that is otherwise sitting there doing nothing else than providing a point for you to put clamps on it and mount it to your roof. But that would require a level of standardization. So now you have to, as a part of your business model, you've got to imagine a world in which a groove on all 4 sides of a solar panel is licensed to most of the major module manufacturers in the world. Module's a panel, by the way, they're interchangeable words in our world. So all of them would standardize on something willingly and actually spend a little bit of extra money because it costs money to put a little bit extra metal to accommodate that groove in your panel. But what if you could do that? What if you could get most of the module manufacturers in the world to buy into the notion that that would drive a lot of labor, a lot of extra material, and increase the roof pace of workers and get more of your products into the market faster? Well, we brought that exact proposal. I had to bring that to many different lobbies of manufacturing facilities in China to try to sell exactly this concept. The good news is, and I think a cautionary, not cautionary tale, but something that's a learning for anybody who's starting out and trying to gain purchase in a marketplace, is find those early pilot customers, find an early believer, and we did find one. And luckily, it was just large enough to scare the hell out of the rest of them as soon as we began showing results in the marketplace. This groove would be married to something that we developed in tandem, which is this: a suite of very lightweight parts that anybody could hold in their hand, put in a pocket or into a vest or other things and bring onto the roof, and very quickly attach one module to its neighbor. Very quickly, anywhere along the exterior of that frame or of that array, place a leveling foot, insert it into the groove, and have it extend roofward, and attach anywhere on the roof to very quickly install. All of that done with a single tool, which I'll show you. This tool is all any installer would need to do 100% of a solar array install from soup to nuts. There are no bolts, there are no washers, there are no screws. There's nothing, as we used to say in our business, that was fumbly, that might fall off and go into the gutter or onto the lawn in front of you. So it's a single tool, very small parts, no rail, and it made a difference, as it turned out, in our marketplace. So we set about popularizing with installers around the United States on the ZEP system, and we brought them a very simple message. With your same crews, you get 5 times the work done. You've got 3 crews right now. They're doing 12 projects a month. How would you like to be doing 34 projects a month? How would you like to be, in our case, stocking 80% fewer SKUs? None of those bolts, none of those washers. The entire wall of rail goes away. How would you like to be making it much easier to load your trucks in the morning because you don't have to cut and measure and make sure that you've got everything that's required for your project, including all that custom rail? How'd you like all your grounding to be done by one single lug, one connection on anywhere at the exterior of the array instead of grounding every rail one to another to another? Very costly and time-consuming exercise. Easy to configure the rooftop. You could pixelate those panels any way you want. It made it very, very flexible for you to take up more of the roof and get larger, more creative systems. All the inventory that we talked about before goes away, and it just looks better. It's closer to the roof. And at the end of the day, this was the picture that made most of our selling possible. Remember those 4, 5, 6 people spending 2 or 3 days doing one install? These are 3 actual homes that were all done by one 3-person crew in 1 day. We showed this to Solar City, largest at that time, the largest installer in our country by far, and very, very tough buyers at that. And they had only open jaws as they looked at this, imagining what that meant for the competitors that were coming up their tailpipe, imagining what it would mean in their hands if they had that power to bring to market. So how did it end up? So within 4 years, we were 50% of the mounting systems market in the United States. We had most of the largest installers, including the largest of them, Solar City. We had 8 of the top 10 module manufacturers and ultimately about 20 of them in all, licensing our technology. And by the time we got to 2013, we were the object that nobody could avoid. And so, as was mentioned earlier, for a little less than 160 million, we were acquired by Solar City, and all of my team joined that company at that time. They went on, by the way, because if you asked us around our room, what do we really care about? We care about impact. They went on, I'm very proud of this, to continue driving costs down inside of Solar City and ultimately Tesla Energy for a period of another 3 or 4 years. So very, very meaningful impact, very, very, I think for our team, a meaningful exercise and something that created and caused to endure a team of really talented mechanical engineers whose skills are going to become pretty important in the story if we roll forward. So, a lineage. My current company, I'm the chairman and CEO at a company called Ojjo. It's not very far away from here. It's about an 8-minute drive from where we are. It's in the same office park as where where ZEP Solar was formed and grew. But as I mentioned, so that was a 2009, ultimately acquired by Solar City, and then consumed, as we probably all know in this room, under certain circumstances by Tesla, and became Tesla Energy. Well, that entire group, all of my engineers, they remained there fruitlessly for the most part, working on the solar roof, and many other Muskian ideas, sometimes satisfyingly so and sometimes not. But the founder, Jack West, my partner in ZEP, began having certain ideas about other ways we could take mechanical engineering concepts and, again, drive materials and labor out of the process of installing solar so it faces the sun. And that caused all of us to double back or triple back down together to form Ojjo in 2018. Let's talk a little bit about what Ojjo does for a living. All right, so you probably all have seen utility scale solar. It winds up looking like this. It's quite beautiful, sometimes quite large. It looks great there, but this is how it starts. So it starts with an empty field and a bunch of folks using a combination of drills and cranes and pile drivers, et cetera, to pound I-beams. You would look at it from one angle and call it an I-beam. In our business, we call it an H-pile, and you pound those things into the ground. Unfortunately, that process is becoming much more difficult given the kinds of soil conditions that exist today. We do that, by the way, we choose that H-pile for a pretty good reason. It's a brute force answer to a very, very awesome set of requirements. You've got to hold back, imagine a row of solar panels that lasts, or that runs between me and the end of this building. All of them look a lot like an airplane wing, and they're catching wind. So that is an awesome force for a utility scale foundation to have to absorb. And so brute force kind of requires us to use something very, very big, driven very deep into the soil in order to hold back those forces. Well, our approach was to rethink that and use the laws of physics a little bit more elegantly and repurpose a truss. Now, we use trusses to build bridges and lots of other weight-bearing things because they have some magical properties. One of them is they're typically able to abide the same amount of load with about half the material. And not only with about half the material, but typically embedded more shallowly into the soil when you're using it for the purposes of a foundation. So this was the first recognition on the part of our engineering team, is that this is an effective but a wasteful way to put a foundation together so that it can offset those very big wind forces we were just talking about. But that's kind of only half the battle, because we've got to install that in something which is very, very unfriendly. Just a quick aside, we chose to engineer these trusses as a series of components. A screw anchor, which is its own component, a steel leg tube that slides on top of that, and finally a cap, we call it a truss cap, which is optimized for whichever tracker, single-axis tracker product we're going to install on top of it. We have all of those as separate components. They get assembled in real time in the field in exactly the position that is required for the given installation that we're engaged in. There's one really important feature for that screw anchor that I'll highlight in just a moment, is that it's hollow. That allows us to slide a drill bit down through that hollow opening and drill the soil directly ahead of that screw anchor for the following reason: that we are not installing in agricultural land in utility scale solar anymore. We've kind of already done full Starbucks on what the best agricultural land in the middle of California right next to power lines are. We're kind of running out of that space. So developers are increasingly having to install in very rocky, low bedrock environments, and those require a fair amount of extra time and effort. First, usually a drill has to show up, a very expensive, like $1.2 million drill machine, many of them with crews that are highly skilled and very expensive. They'll drill holes, then they'll be followed by another set of folks driving another set of machines called pile drivers to drive piles into each one of those holes. And then, because that soil is really crappy, and as those piles are going in, they're getting torqued and refused, so some are higher than the other, some are twisted out of shape, some of them are just flat out uninstallable. So a third crew and a third set of machines comes in to do something they so politely call remediate. So that means we bang into them, collide with them, cut them off, weld stuff on top of them so I have a planar surface on which to put a torque tube that can roll with the sun and support these tracker products. Well, we've replaced all of that with a single, very intelligent machine with a lot of autonomous software of our own design. It's called a truss driver. We have about 50 plus of these right now. They are capable of, on an angled basis, drilling precisely into the soil, often difficult soil, a varying level or a varying array of drill bits and techniques are employed in order to overcome the particular soil problems and to get absolutely dead accurate the tops of every one of these trusses, such that when a laser runs down a line, and this is not just some beauty shot, this is what we do. This is row 2 on Thursday. This is what we do for a living. But a single operation allows all of those truss components to be very precisely located with less steel, less labor, and literally millions of dollars in savings to the construction companies that are working these projects. Someone will wonder, what's our business model? Very quickly, we sell that hardware. We own and rent these machines to the construction companies that need them, and then we train them in the proper use of them. We don't man them ourselves. We allow them to do that. But we've wound up doing some of the largest, most challenging projects in solar, from caliche soil in Nevada, which is the hardest soil in the country. If I banged it with a hammer, that hammer would bounce back in my face. A range of projects out in the Nevada desert with some of the larger solar installers in the country, and then one that we're particularly proud of. This is the largest project, solar plus storage, in the United States last year. It's called Gemini. It's almost a gigawatt. It is, as you can see in the upper right-hand corner, for scale, it's the size of about half of Manhattan. You can see this from space. It is, thank you. It is a wonder to go see. And this is our attempt to try to see a part of it from a drone, but it really does, it evades capture with traditional photography. But this is kind of where we are, and I'll try to quickly wrap up. I think I'm at dead zero, yes. So we've raised, as mentioned before, about $70 million. We're in the middle of our journey here. We're approaching 5 gigawatts worth of either installed or contracted work. 50 employees, all here or most of them here in Marin. A big fleet and a big opportunity ahead of us. Stay tuned. There's more to it. But I'm here because I was lured out here as an employee of Autodesk. So talk about folks who invested in the local community, made it happen. They made a magnet that was big enough and powerful enough to draw talent here from all over the world. I got swept up in that, and that's the reason I'm here, to have a startup journey. And I think that's what everybody in this room ought to aspire to. Go build something that brings the rest of us here, that brings more of us here. This is the last slide, I promise. And there's a reason why we're choosing to build here and why we're doubling down here. Great networks, great people, local institutions that are kicking out great talent every year, including Cal Berkeley, just up the road, Cal Davis, many of whom are sitting on my staff right now, working very hard at CAD stations not too far from here. And I think, importantly, each one of you, let's all commit to doing more of this. Let's commit to sharing and networking more, supporting each other. Thank you, Zach and MSIV, for doing exactly what you're doing, hyper locally. But we can make this economy, we can make this part of the Bay Area more productive, more vibrant, more profitable by taking advantage of what's in this room and what's in our community. And I'm really encouraging everybody to keep their head in the game. So thank you very much for your time.